Okay, we have here another integral today. This one's from the UK integration bee sample problem number 15. We have the integral of 1 over x cubed plus 1 dx. Okay, of course, this looks pretty simple. There's not a lot going on here, but it's actually a little harder than it looks. It's kind of a grind to do this one. So for my first step, what I want to do with this, let's just see if we can factor the denominator and then maybe do partial fractions on this. So what we can do here to rewrite this is let's just look at this as a sum of two cubes. And then we can use that formula over here and split this fraction up. So the first part is just going to be an x plus 1. And the rest of it's going to be x squared minus x plus 1, I think. And then what we want to do for partial fractions is split up these two pieces. So the first one we're just going to have some constants we're going to solve for. So the first one I'll write as a over this piece, x plus 1. And the second part, because this is a second degree polynomial, we're going to need two terms. We're going to need something like bx plus c over here for the second piece. And then for this first term, I can just use the cover-up method on this. If you set x equal to minus 1 here, you plug that in, you have a 0 here. You cover that up so we're not dividing by 0, and we just need to plug this in over here. When you do that, minus 1 squared is 1, minus times minus is a plus 1, plus another 1, that gives me 3, 1 over 3. Our a value is going to be just 1 over 3. And then next for our b and c value, what we can do is just start plugging in some common values. So an easy value to use here is going to be x equal to 0. So we're just going to plug in 0 everywhere we see an x. So over here we're going to have 1. This first piece is going to be 0 plus 1 or 1. Here, zeros, this is just going to give me another 1. So everything here, that doesn't really make sense, but everything on the left side is just going to be a 1. Then coming over to the right, we have our a is 1/3, so we'll leave that as 1/3 over 0 plus 1, that's just 1, so we'll leave that off and we just have a 1/3 here. Plugging in zeros on the, plugging in 0 here, we're just going to have a c in the numerator. Plug a 0 in here, and we're just left with 1. So just to clear this up, we have c plus 1/3 equals 1, which means c must equal 2/3. So we'll put that right there for our c value. Okay, now for the b value, we've already used x equal to minus 1. We've used x equal to 0. Let's try just x equal to 1 now. So if we do that, we're going to have our 1 in the numerator here. This is going to become a 2. Plugging 1 in here, this first part's 0, and then we just have another 1 right there. So this whole piece is going to be 1/2. Then next, plugging the 1 in here, we're going to have 1/3 over 2. 1 plus 1 is 2, so this is going to be a 1/6 here. Then plug a 1 in here, we're going to have b plus our c value, which is 2/3. 1 in here, these terms 0 out, we just have a 1 there. Then just to clean this up, I think what I'll do is multiply in a 6 on both sides. Sorry if this is confusing the way I'm doing this quick. Don't pay attention to that. Multiply in a 6. What we're going to have here is on the left side 3, 6 times 6, 1, plus 6b. 6 times 2/3 is going to be a plus 4. So then reducing this, we have on this side we have 6b plus 5 equals 3. Subtract 5 on both sides, 6b equals minus 2, or b equals minus 1/3. So now going ahead with what we found here, let's take all this stuff and put it back into an integral and see what we can do. I've actually split this up into two integrals, I think. So for the first one, I'm just going to have 1/3 dx over x plus 1. That one's going to be easy for us. Then for this next one, I'm not really sure if I remember what needs to happen. Let's factor out a minus 1/3 and see if that cleans it up a little bit. So doing that, in the numerator, we're just going to have an x here, and this second term is going to become minus 2 in order to get back to 2/3, and then we'll have this same denominator right here. But now for this right here, I want to set up a u substitution. This should be pretty easy to make work. So we're going to have u equal to this right here. Take a derivative for our du value. This is going to become 2x minus 1 dx. So now trying to set up this du the way we want it, if I multiply in a 2 here, I need to also do it on this term. So 2 times minus 2, this becomes a minus 4. I don't want to change it, so let's multiply a 1/2 in front. But now I don't really want this 4 here, I want 2x minus 1. So what I'm going to do is force this minus 1 to happen and break off a minus 3, which I'm going to take, and we'll have to create a third integral with that. So going ahead with this, the first one, this is going to be just 1/3 natural log absolute value x plus 1. Here, minus 1/3 times minus 1/2 is going to be minus 1 over 6. And then I'm not going to formally do out this because we can see that we've got u in the denominator and we've got our du in the numerator. So this is just going to be like du over u, and so this is going to be natural log absolute value of u, which is just this, x squared minus x plus 1. But it turns out this is always positive, so I'm going to drop absolute value here, make that parentheses. And then all we'll have to do is deal with this minus 3 in a separate integral. So let's see how that's going to look. We'll have breaking this out into this integral. The thing is, we have minus 3 times this minus 1/6. This is going to become a plus 1/2 in front. And this derivative is going to be dx over x squared minus x plus 1. But let me just get more space and we can deal with this integral over here on the next board. Okay, now here I just want to deal with this integral over here separately. And first what I can do here, on this denominator, let's just complete the square on this and rewrite it. So when we do that, let's see, this is going to become, like think of the coefficient here as 1, and then take half of it, so we can write this as x minus 1/2 squared. You square that out, you get x squared minus 1/2 x gives me my minus x plus a 1/4. Well, we need to get back to 3/4 so we don't change it. So if I add 3/4 to this 1/4 here, we get back our 1. But now just to set this up to integrate, what I want to do is write this as something squared. So what I can do is change this to square root of 3 over 2, and then I can write this thing as squared. But now from here, for this integral, we can just use our arctan formula. It's all set up where for this a value, this is going to be this right here. And in both cases, we're taking the reciprocal of that. So like 1 over a is going to be just equal to 2 over square root of 3. So using this here, what we're going to get is 2 over square root of 3. Then we're going to have just arctan of our x here, which is just this. So it's actually going to be x minus 1/2. And then this reciprocal of a, so this is going to be this 2 over square root of 3 again. But then just cleaning this up a little bit, let's just multiply in this 2 right here. So coming down here, we're going to have 2 over square root of 3, arctan, multiply it in, we end up with 2x minus 1 over square root of 3. And one thing I actually want to do is simplify this. Let's just bring this 1/2 into it. I should have done it originally because it's going to help us simplify. So if we have 1/2 on all this, right, and then we have 1/2 here, that's just going to cancel out. And here we're going to have just 1 over square root of 3. So all we need to do is take this and plug this back in, and then that's going to finish it off. So for my final solution of this, we just have 1/3 natural log absolute value x plus 1 minus 1 over 6 natural log x squared minus x plus 1. Then this last piece plus 1 over square root of 3 arctan 2x minus 1 over square root of 3, add a plus c, and that's it. Okay, there you have it. Kind of surprising how much work there is in such a simple integral like 1 over x cubed plus 1. Thanks everyone for watching. Have a good day.